Hi, let's talk how to do percent composition. So for these percent composition practice problems, let's consider the fact that when we say percent composition, we mean by mass and not by number. So yes, this molecule is 50% nitrogen and 50% oxygen by number, but because nitrogen and oxygen are not the same mass, it is not 50%, it is a different amount. So let's go about how to find what percent mass nitrogen is of the entire molecule, what percent oxygen is of the entire molecule. First step is going to be to find the molar mass. So molar mass of nitrogen monoxide. So that's going to be, just to be clear, from the periodic table, we're going to round to the hundredths place, and we're going to call it 14.01. Don't forget units of grams per mole for nitrogen, plus the number that for oxygen's molar mass is going to round to 16.00 grams per mole. Again, straight off the periodic table. And then when you add that together, that comes out to that number, 30.01 grams per mole. So there, I guess it's not more or less visible now. 30.01 grams per mole NO. So what we're going to do is we're going to say that nitrogen, we're going to take the mass of nitrogen divided by the total to find what percent nitrogen is. So here's how it looks. 14.01 grams per mole nitrogen divided by 30.01 grams per mole nitrogen monoxide. That's going to get a decimal, and the decimal will be that, which we'll write as 0.4. And how many sig figs do we need, by the way? This is 4 sig figs, this is 4 sig figs, so we're also going to round this to 4 sig figs. And so that'll be 0.04668 times 100% equals 46.68% nitrogen. So this is for nitrogen, and then we're going to say that's that. So we should have a chemical identity on everything. This is a rare unitless number because grams per mole cancels grams per mole, and then multiplying by 100%, we get a unit again, that percent nitrogen. Technically, it's that percent nitrogen with regard to NO, but we'll just leave it like that. So that's only one of it, though. We need to do both elements. When we say percent composition, and we ask percent composition, we want both elements. So 16.00 grams per mole oxygen divided by 30.01 grams per mole nitrogen monoxide, like that. And that's going to equal that decimal, which, again, we're going to notice 4 sig figs, 4 sig figs. So the decimal is going to be 0.5332, that's oxygen, times 100% gives you a 53.32% oxygen. And that is how you're going to deal with that. And then what do you do for the answer? Well, box it. Now, when you look at other elements, it's going to be the same way, or should I say other compounds, it'll be working in the same way. Let me just get a couple things so I can get this all in view. Okay, let's do this one now. Ammonia. Same thing. Nitrogen is 14.01. So we're going to do 14.01 grams per mole nitrogen plus 3, and then hydrogen rounds to 1.01. Oops, there you go. Now you can see it. 1.01 grams per mole. That's for hydrogen. And the total mass for that will be that, which we'll put as 17.04 grams per mole NH3. And so now with that, we're going to do the same thing what percent mass is nitrogen out of all of it. So nitrogen is 14.01 grams per mole divided by the total mass of 17.01 grams per mole NH3, like that. And we're going to get a decimal of that. And by the way, I did fix it because I just realized I wrote 1 instead of 4. But anyway, the decimal is that. 4 sig figs, 4 sig figs. So this decimal better be 4 sig figs. 0.8222 times 100% equal, and that's for nitrogen, and times 100% equals 82.22% nitrogen. And then we're going to do the same thing for the hydrogen. We saw a total mass of that. Well, what is that? That's 3 times 1.01. 3 times 1.01. The total mass of hydrogen is this within the formula. So I'm not going to put 1.01. I could write this, but it's the same as writing 3.03 grams per mole of hydrogen. I suppose maybe just to keep it a little nicer looking, maybe I will put 3 times 1.01, but this is 3.03 for the hydrogen. And then what we've got down here is 17.04 grams per mole of the NH3. So that's going to be 3.03 on top. That's going to be 17.04 on the bottom. And 3.03 divided by 17.04 gives an answer of that much. Now, that is 3 sig figs. That is 4 sig figs, right? 3.03 is what this will be. We're going to round this to 3 sig figs. Equals 0.178. See how that rounds to 0.178? And that's for hydrogen. Times 100% equals 17.8% hydrogen. Box both answers because together they constitute the single answer for this question. So that's how you handle that one. When it comes to heavier stuff, well, actually, before I say that, water is going to work the same way. So the same process, you're going to use 2. For water, you'll use 2 hydrogens. You'll use 1 oxygen because there's just 1 oxygen in the formula. So I don't feel a need to show that in this video. For uranium, it's really going to work the same way. And for deoxyribose, it's going to work the same way. And just to show it for the sake of showing it, I suppose, we'll show how to do the deoxyribose. So deoxyribose is part of the structure of DNA. So 5 carbons, 10 hydrogens, and 4 oxygens. So that's 5 times carbon, which is 12.01 grams per mole. That's carbon. Plus 10 times the mass of hydrogen. That's 10 times 1.01. That's hydrogen. Plus 4 times the mass of oxygen, which is 16.00. And then, oh, I just realized I did a terrible, terrible thing. Let's fix that. Please don't do what I just did, because I left out units. 1.01 grams per mole, that's for hydrogen, plus 4 times 16.00 grams per mole, and that's for oxygen. So C and all that together equals, actually let's just go straight to putting the number, which will be, oh, my apologies, I just realized after all that talking that this was off screen, not even visible. There we go. That's much better. And so what this is going to be is going to total it to what this is going to give, 134.15. So 134.15 grams per mole, C5H10O4. So that's the total mass. So I'm going to have to find what percent carbon is, what percent hydrogen is, and what percent oxygen is. So let's do carbon. And I'll do that over here. 12.01 grams per mole. That's going to be 5 times that. That's for carbon. That'll be over the total mass of 134.15 grams per mole, C5H10O4. Now, for your work, is it okay to just write 12.01 times 5 and like 60.05 up here? Yes, I suppose it's fine because that's what it's going to come out to. But nonetheless, I'm just showing why I'm doing it this way. So 60.05 divided by 134.15 gives a decimal. That's going to have 4 sig figs and 5 sig figs. So 4 sig figs, 0.4476. That's the ratio of carbon. Technically, that's a ratio. Let's turn that into a percent, which is 44.76% carbon. Let's do the same thing for the other ones. 10 times 1.01 grams per mole hydrogen divided by 134.15 grams per mole C5H10O4. And then we're going to calculate that decimal, which is, that's the total mass of the hydrogen, 10.1. So 10.1 divided by 134.15 is that. We're going to use 3 sig figs because of that number right there. So that's going to be 7, 5, and 2. So 0.0753. That's the ratio for, not carbon. That's the ratio for hydrogen. And then times 100%. That's going to give you a 7.53% hydrogen. And now for the last one, oxygen. So there's 4 oxygens times 16.00 grams per mole. That's for oxygen. And we're going to divide that by the grand total molar mass of 134.15 grams per mole, C5H10O4. Now, 4 times 16 is 64. So this is going to be 64.00. 64.00 divided by 134.15 gives that. So we're going to write the decimal 0.477. How many sig figs? This is 4, this is 5, so we're limited to 4. So 0.4771. That's the ratio of oxygen. And we're going to multiply that by 100% to get 47.71% oxygen. And we box that as the total answer. And if we do the math, it actually does add up to 100%. Close. All right. Though I've not shown everything on this worksheet, these two I haven't shown work exactly the same way as the ones that I did. So that's how you do it all.